Two AI models walk into a bar. One thinks for 2,000 tokens before writing a one-liner. The other just writes it. Today we are putting Meta's brand new Muse Glimmer 30B against Qwen 3.6 27B on an AMD GPU, running real Hermes agent tasks, not synthetic benchmarks. Let's see who overthinks. Meet the contenders. In the left corner, Muse Glimmer 30B dropped August the 10th from Meta. 30 billion parameters, built-in vision, a speculative decoding trick called dFlash, and an attitude that says, I can run agents. In the right corner, Qwen 3.6 27B, the reigning champ of terminal coding, 27 billion parameters with native vision 2. No dFlash, just raw coding chops. Both Apache 2.0. Both fit in 32 gigabytes of VRAM. The question is, which one actually gets work done? The arena, an AMD Radeon R9700, 32 gigs of VRAM, GFX 1211 architecture, 0 NVIDIA inside. Most benchmarks you see online are running on RTX 5090s or DGX Sparks. Cool for them. But you watching this probably have an AMD card or a 12 gig NVIDIA. So we are testing on real consumer hardware with Ollama, the way you would actually use it. The test harness is Hermes Agent, an open source AI agent platform for real agent tasks. Same prompts, same code start. Let's go. Test 1. Write a Python one-liner to read a JSON file and print all keys. Simple enough, right? Glimmer spat out the answer in 528 tokens. Qwen took 2,033 tokens. Same answer. Both correct. But Glimmer finished in 39 seconds and Qwen took 90. That's not a speed difference, that's a thinking difference. Glimmer just walks in and does the job. Qwen writes a novel about why the job matters first. Test 2. Build an image corruption scanner. Find all JPEGs and PNGs, check each one with PIL, move broken files to quarantine, generate a report. Glimmer delivered the complete script in 75 seconds. Clean code, outpass CLI, preserves folder structure, saves a report file. Qwen still thinking. The under the second timeout hit. Qwen literally overthought itself into a DNF. That's right, the coding champ didn't finish. Sometimes more reasoning isn't better reasoning. Test 3. Debug an ffmpeg command that produces a black screen. This is a real bug I hit making videos. The crop filter uses commas instead of colons, and ffmpeg silently parses it as two separate filters. Both models nailed it. Glimmer in 10.06 seconds, Qwen in 20.06. Both spotted the comma versus colon issue. Both gave the fix. Glimmer was 16% faster, but honestly, this was a tie. Both models know their ffmpeg. Respect where it's due. Test 4. Build a shift tracker CLI for a gas station worker. Clock in, clock out, weekly hours, saved to JSON. Both delivered complete working scripts with argpass. Both had JSON storage and weekly summaries, but Glimmer finished in 91 seconds with 2,300 tokens. Qwen took 208 seconds and burned 5,500 tokens. Same quality output, 2.4 times longer. At this point, a pattern is emerging. Qwen thinks more. Glimmer ships more. Here are the numbers from the AMD R9700. Both models run 100% on GPU. No CPU offload. On Ollama with ROCm, decode speed is nearly identical, about 29 tokens per second for Glimmer, 27 for Qwen. VRAM usage is close to 20.6 gigs for Glimmer, 21.2 for Qwen. Total tokens across all tests, 7,193 for Glimmer versus over 10,000 for Qwen. Total time, 31 seconds versus 4,104 seconds. Per token, the difference is how many tokens each model decides it needs. But here is where it gets interesting. We built llama.cpp from source with ROCm and enabled dFlash speculative decoding. Same GPU, same model. Glimmer jumped from 29 tokens per second to nearly 50. That is a 1.7x speed up. No new hardware, just software. AMD claims 53 on Vulkan. We hit 49.9 on ROCm Linux. Close enough. Now, here is the honest take. Glimmer is not better at everything. Qwen 3.6 beats it on Terminal Bench by 9 points and OS World by 10. If you need a model to drive a computer and click through real terminal sessions, Qwen is your pick. Both models have vision, but Glimmer uses a larger G14 encoder, and dFlash is not magic. We tried it on Vulkan first. Completely failed. RADV does not support shared memory between model contexts. Rocks, but you have to build llama.cpp from source. Ollama does not support dFlash yet, and the human evil gap is real, 82% for Glimmer versus 92% for Qwen. Code correctness matters, so which one should you run in your Hermes agent? If you want an agent that writes code fast, uses less VRAM, and does not burn tokens overthinking, Muse Glimmer 30B. And if you build llama.cpp with ROCm and turn on dFlash, you get 50 tokens per second on an AMD card. If you need the best terminal execution and do not care about wait time, Qwen 3.6 27B, both have vision, both are free, both run on AMD, both fit in 32 gigs. Download them with Ollama Pool, point your Hermes agent at them, and try the tests yourself. The prompts are in the description. I'm Mike, this is BizFlowAI, and I'll see you in the next one.